When the data in original form before they are grouped or ranked, they are called raw data. The data can be organized into different categories using table or diagrams. 4.2a Qualitative data. This section discusses how to organize and display qualitative data. Data sets are organized into tables and data are displayed using graphs. When the data are qualitative, pie charts and bar charts can be used to represent the data. Example, 50 accounting students in KMP were given a blood test to determine their blood type. The data can be categorized into the categorical frequency distribution. A categorical frequency distribution for qualitative data lists all categories and the number of elements that belong to each of the categories, whether nominal or ordinal level data. Here is the categorical frequency distribution. So blood type represents the class of the distribution and the frequency is about the number of KMP students. Pie chart. Commonly used to represent the relative frequencies or percentage of a population or a sample belonging to different categories. To construct a pie chart, use this formula. Degree measure or size of the angle for the corresponding category equals to frequency over total frequency times by 360 degree. This is the pie chart for blood type. Each segment represents the categories of blood type and the frequency of students with their blood type. Example, 42% of the students have blood type O. Bar chart represents the data by using vertical or horizontal bars whose height or length represent the frequencies of the data. This is the bar chart of the blood type. Horizontal axis represent the blood category and the vertical axis is about the number of KMP students of each blood category. Example, there are 10 students have blood type A. 4.2b Quantitative data displays the frequency of each individual data value, rather groups of data values. A frequency distribution for quantitative data lists all the classes and the number of values that belong to each class. Look at the example. The number of male children in 20 families chosen at random is as follows. This is given the raw data. Frequency distribution table. Here is the frequency distribution table of the example. Table lists the number of male children as the class, the number of family as frequency, and cumulative frequency that we use to construct an ogive. For example, there are 2 families that have 1 male children only, and 3 families that have 4 male children. Histogram. A graph in which classes are marked on the horizontal axis and the frequencies, relative frequencies or percentage are marked on the vertical axis. The frequencies, relative frequencies or percentage are representing the height of the bars. This is a histogram about the number of male children. Class are marked as the number of male children on the horizontal axis, whereas the frequency are marked as the number of families on the vertical axis. The number of families that have certain number of male children will show by the bar of the histogram. For example, there are 7 families that have 3 male children in their families. Frequency polygon, a graph formed by joining the midpoints of the tops of the successive bar in a histogram with straight lines. Here is the frequency polygon of the number of male children. Ogive represent the cumulative frequency for the classes in a frequency distribution. The cumulative frequency is the sum of the frequency accumulated in the distribution. So here is the cumulative frequency of the example. The ogive represent the number of male children of the example given. Horizontal axis represent the classes and the vertical axis represent the cumulative frequency. 4.2c Stem and leaf plot. What is stem and leaf plot? A data plot that uses part of the data value as the stem and part of a data value as the leaf to form groups or classes. Step to construct a stem and leaf plot for a data. Step 1. Arrange the data in ascending order. Then step 2 is separate the data according the first digit. And step 3, a display can be made by using the leading digit as the stem and the last digit is the leaf. And last one, step 4, state the key for the stem and leaf value. The advantage of this method is the displays lists out all the original data. The method allows the shape of the distribution of the data to be clearly seen. There are 3 common types of distribution. So first is the bell shape. From the diagram, it is found that the same amount of data at the end of the plot. Hence, the data is symmetrical skewed. The second is skewed to the right. We can see that the majority data found at the start of the plot. Hence, the data is positive skewed. The last is skewed to the left. The majority data found at the end of the plot. Hence, the data is negative skewed. Look at the example. Construct a stem and leaf plot for the data below. Now, let's discuss the solution of the example. So, follow the step. First, arrange the data in ascending order. So the lowest data is 12 and the highest data is 41. For the second step, separate each score into two parts, namely the stem and the leaf. Since all the scores consist of 2 digits, let the stem be the first or leading digit and leaf be the last digit. Data 12 and 13 have the same stem with the first digit is 1. And the second digit of 2 and 3 as the leaf. Arrange all the scores in a vertical manner from the smallest score to the biggest score. For each stem, the leaves are arranged in ascending order from the left to the right. There are two scores with a score of 40. So we have to write 40 two times. And the last step is include a key to explain the meaning of the entry. So 3 as stem and 4 as the leaf means the data is 34. Next example, complete a stem and leaf plot for the following list of the grade on a recent test. Hence, determine the skewness of the data. Now, we are going to discuss the solution of example. So first step, arrange the data in ascending order. So the lowest data is 42 and the highest data is 99. Since the data consists 2 digits, let the leading digit be the stem and the second digit or the last digit be the leaf. Arrange all the score in vertical manner from the smallest score to the biggest. So start with the first data, 42, 67, 73 and 78. And next we have 82, 84 and 86. And the last one is 91, 94 and 99. Don't forget to include the key. So 8 is the stem and 2 is the leaf, means the data is 82. Now determine the skewness of the data. So I will show you the pattern from the stem and leaf plot. Okay, since the majority data found at the end of the plot, hence the data has negative skewness.